talking about how we can graph points with rational coordinates on a coordinate plane so that we can find the distances between the points. Specifically, we're going to know how to plot rational ordered pairs. We're going to use absolute values to find the distances between 2 points, and we're going to use the perimeter to help us extend what we know already. If you haven't watched the 2.5 distances between 2 points video, I would suggest watching that first. Otherwise, it's not going to make a whole lot of sense. In terms of learning experience, we're doing a mini lesson. It's going to have 2 parts to it because there are 2 ways you can do this. You're going to do a you-do. There will be things to remember, the key points for this video, and then, of course, suggested practice problems at the end. So let's start by figuring out how we can find the perimeter of a rectangle in one way. So we have these 4 points, A, B, C, and D. And when we plot them on a graph, they're going to make a rectangle. So let's start by doing that. Our first point is at 3, 3. So it'll be right there. We can just label this as point A. Point B is going to be at -2, 3. So we'll put our point there. Put a B right there. C is going to be at -2, -3. We're going to put a point here. Label this as C. And D is at 3, -3. So it's going to be right here. Now you'll notice, of course, since we know that these should make a rectangle, if we connect all of our points A to B, B to C, C to D, and D to A, they make a rectangle, to the best of my drawing abilities at least. As for finding the perimeter, it's actually really easy. All we need to do is we need to look at our scale. We can see that each box represents 1. So we're just going to count each box as 1. So we've got 1, 2, 3, 4, 5. So this side is going to be 5. If we go from B to C, it'll be 1, 2, 3, 4, 5, 6. So this side is 6 units. We could do the same thing with the distance from C to D and D to A, but given the fact that this is a rectangle, we should know that this side should be the same as its opposite side, as should this. So the last step then is just to add all of these together. We have a 5, plus a 5, plus a 6, plus a 6. 5 plus 5 is 10. 6 plus 6 is 12. And 10 plus 12 is 22. So we know that the perimeter here should be 22 of whatever units we're using right now. Now, this is great. It takes a little bit longer, though, because you have to first make a coordinate plane. You have to label your axes, you have to label your scale, and then you have to plot your points, make your rectangle, and then measure it. It's an effective way. If it works for you, there's no reason not to use it. It's just not the fastest way we could do this. If you prefer it, though, you can certainly do it this way. A slightly faster, but perhaps slightly harder way to do this is to use the absolute value method that we learned in the 2.5 video. If we take 2 of our points, such as A and B, we can compare our x and y values and see which ones are the same. In this example, the x's are the same, so we're going to ignore, the y's are the same, so we're going to ignore them. Since these are different values, one's positive and one's negative, we're going to add them. And then we're just going to take the absolute value of the 2 values that we didn't cross off. So we have 3 plus 2, which is equal to 5. So the distance from A to B is just going to be 5. We already know that because we did it the other way as well. But you'll notice that was a lot faster than plotting your points and making your graph and doing all that stuff. This whole thing is just for speed. We can do it again for B and C. Point B, we already know, is -2, 3. C is going to be -2, -3. And if we do the same thing that we just did, this time our x values are the same, so we're going to ignore them. We still have a positive and a negative value, so we're still going to add our absolute values. And when we take them, we get 3 plus 3, which is 6. We already know that because we know that this was supposed to be 6. Now, because we know that this is a rectangle, we can actually stop there. If this was a different shape, a more complex shape, we might have to keep going, do each of these individually. But since we know that this is a rectangle, as we mentioned earlier, we know that these two sides should be the same, and that these two sides should be the same. So if we just take the two distances that we've already found, multiply them by 2, we get 10 and 12. And then just like in the previous example, we just need to add them up, and we'll get 22 units. Now, this might look harder, and it might be, but it's a lot faster to do. Especially if you have a rectangle, you only need to do 2 quick either addition or subtraction problems, and then a little bit of multiplication, depending on what it is that you need to do. Again, you don't have to use this method, but it's up to you. Use the one that works best for you. Now it's time for a you-do problem. In this problem, you have an archaeologist who used a coordinate plane to map their dig site. She marked the corners of a building with flags, which you can see in this image. How much rope is she going to need to go around the building? So think about how this connects to what we just did. Looks like you're going to have to pick one version since it doesn't give you the coordinates for A, B, C, and D. See what you can do. Ready? Go. So remember, there are 2 methods you can use to find the perimeter of a shape on a coordinate plane. You can either plot your points on a coordinate plane. This works best if you have points to plot, or if you've just got a shape on a coordinate plane already. It's a little bit longer to do most of the time, but sometimes it works better. Alternatively, you can use the absolute value method. That's only going to work if you have the coordinate points already, and you want to save some time by not graphing them. Make sure that your shape is a rectangle if you want to skip a couple steps, but you can use that as well as if you prefer. Overall, just choose whatever works best for you. Go with that one. Sometimes you can only use one, sometimes you can only use the other one. It depends on the problem that you're working on. So pick the best one for you for the situation. Finally, we're going to leave you with a few different practice problems. Those first 2, they don't necessarily give you the coordinate points, so guess which method you're going to have to use. As for 3 and 4, those are more like what we saw in the mini lesson, so you have a choice as to which method you want to use. You could use the plotting points method, or you can use the absolute value method. Whichever one works best for you. Give them a shot. Good luck.